You're listening to DTFHN for April 16th, 2026. I'm your legacy-haunted host, Jack Hacksman. We are your daily tech feed for Hacker News. A website will occasionally outlive the companies they're about. Today is about old bones, stubborn systems, and the slow cost of choosing who gets the keys. Let's crack the shell. IPv4 has just crossed 50% of Google's traffic, half the internet by volume, hitting one of the most connected endpoints on Earth, is now running on a protocol that was finalized in 1998. Let's start with the constraint. IPv4 gives you 32 bits of address space, 4.3 billion addresses. That sounded infinite in 1981 when John Postel published RFC 791. The global population was 4.5 billion, and most of them had never seen a computer. By 2011, IANA handed out the last IPv4 blocks. The constraint became real. We patched around it with NAT, with carrier-grade NAT, with IP sharing schemes that are genuinely impressive feats of network origami. But every workaround is a tax. Every layer of translation breaks end-to-end addressability. The foundational promise of the Internet. IPv4 fixes this with 128 bits, 340 undecillion addresses. Enough to assign every grain of sand on Earth its own subnet and have room left over for the sand on Mars. The math is elegant. The transition has been brutal. Here's the historical parallel that matters. In 1983, ARPANET cut over from NCP to TCP/IP on a single day. January 1st Flag Day. It worked because ARPANET was small, centrally coordinated, and everyone agreed the new protocol was better. IPv6 had no Flag Day. It has been a 28-year creeping migration, dual stack by dual stack, ISP by ISP, closer to the slow death of analog television than the snap of NCP to TCP. And look at who got there first. France tops the charts at over 80%. India, Germany, the entire mobile-first developing world. Countries that came online late skipped the IPv4 land grab entirely. The latecomers advantage. Same reason much of Africa skipped landlines and went straight to mobile. Then there are the holdouts. A commenter on Hacker News pointed out that GitHub still does not support IPv6. In 2026, the largest open-source code host on the planet. The reason is mundane and revealing. Flipping the switch would break customers who configured IP-based access controls, assuming the forever, the legacy is the lock-in. This is the texture of real infrastructure migration, not a clean handoff. A decades-long overlap where the old protocol refuses to die because the cost of breaking things is always paid today and the benefit of fixing things is always paid tomorrow. 50% took 28 years. The next 50 will be harder. Speaking of infrastructure that's quietly reshaping itself, what if the next compute layer wasn't a hyperscaler data center, but the idle Mac sitting on your desk right now? Years ago, I worked on a system that needed to verify untrusted hardware was running the code we thought it was running. Harder than it sounds. You can sign the binary, check some of the weights, but the moment code touches a machine you don't own, you're trusting the operator not to lie about what's executing. Darkbloom is taking a swing at that exact problem. At scale on consumer Macs. The pitch is elegant. NVIDIA sells silicon to hyperscalers. Hyperscalers rent capacity to AI companies. AI companies bill end users per token. 3 layers of margin between sand and inference. Meanwhile, millions of M-series Macs sit idle most of the day. With neural engines that can absolutely serve a GEMA model, the arbitrage is sitting there waiting for someone to plummet. The technical substance is where this gets good. They use the secure enclave on Apple Silicon as a trusted execution environment. attesting that the model and runtime haven't been tampered with before any inference happens. That's the right primitive. It's how you get from random stranger's laptop to cryptographically variable inference endpoint. The engineering craft is real. But here's the question nobody in the launch thread wants to sit with. When you install their MDM profile, whose computer is it anymore? Mobile device management is a deep hook. It can install software, wipe disks, enforce policies, see traffic. The TEE protects the renter's model from the host. What protects the host from the platform? This is the architecture question that decides whether a system liberates or extracts. Distributed inference on consumer hardware is genuinely bootstrapist. It routes around the hyperscaler tax, puts compute earnings in human hands, treats the edge as the edge. The SETI-at-home comparison from the comments is apt but inverted. Same topology, different incentive. The path forward is obvious. Open the MDM scope. Publish the attestation chain. Let the host verify the platform with the same rigor the renter verifies the host. Symmetry is how you earn trust at scale. The primitives exist. The market is real. The engineering is most of the way there. The remaining work is governance. And that's the part that decides everything. Moving up. The Free Software Foundation is asking strangers on Mastodon if anyone knows someone at Google. That's the detail worth sitting with. An organization with full-time legal staff, 4 decades of institutional weight, direct relationships with nearly every foundational project on the internet. Reduced to posting on a federated server hoping someone in the replies works at Alphabet. 10,000 spam messages. 1 Gmail account. No reporting channel that produces a human response. Imagine if every postal abuse complaint required you to know someone at the post office personally. Imagine if flagging a fraudulent check required a friend at the bank. We would call that a failed system. We have built exactly that system for email. And email is still how legal notices, account recovery, 2-factor codes, and most of human professional correspondence move. Run this forward 5 years. The trend line is unambiguous. A sysadmin in the comment. 4 postfix servers, watching this for 2 to 3 years. Says Gmail can no longer be whitelisted. Spam, phishing, abuse, all flowing outward, unchallengeable. Meanwhile, inbound mail from independent servers gets quietly filed as suspicious. The asymmetry compounds. Self-hosted email becomes operationally impossible, and the only remaining recipient is the platform that does not answer reports. This is what platform capture looks like in slow motion. A gradual erosion of the alternative until there is no alternative. Paired with a customer service function that exists only on paper. The reader who actually got Google to respond did it by sending a police report to the legal department via certified mail with return receipt. That is the working escalation path in 2026 for a service that handles 1/3 of the world's email. The path out is the path that always works. Federated mail still exists. The protocols are open. The block lists, the reputation systems, the deliverability work. They're hard, but they are tractable engineering problems being actively worked by people who give a damn. Mail cow, stalwart. The new generation of self-hosted stacks. Run your own. Help someone else run theirs. Donate to the projects keeping the protocol alive. When the customer service desk for half the planet's correspondence is a Mastodon post. The fix is not louder pleading. The fix is making sure the post office is never one company again. Moving on. Every code base that survives long enough becomes an archaeological site. The BSD tree, the Linux kernel. You can blame your way back through decades and watch which lines were kept, which got ripped out, which mutated into something unrecognizable. The code running in production today is not the code anyone wrote. It is the code that survived selection pressure. A new paper out of David Reich's lab at Harvard just did exactly this for humans. Ancient DNA from across West Eurasia. thousands of samples spanning 10,000 years, and the signal is unambiguous. Directional selection. Not drift, not noise. Has been reshaping the human genome continuously. Lactase persistence, immune response, pigmentation, height, real measurable pressure favoring specific variants, generation after generation, with time stamps. This is Git log for our species. Authorship, dates, diffs. The researchers can point at a specific allele and tell you it took over between 5,000 and 3,000 BCE. This one swept through the steppe. This one is still actively moving. Take the claim seriously. Run the principle all the way. If selection is pervasive and directional, if the genome is an actively maintained codebase rather than a frozen binary, then there is no baseline human we drifted from. Every era runs its own fork. Every environment applies its own pressure. The species is a moving target and has been moving the whole time, which makes a certain kind of appeal to nature look fatally ridiculous. The thing people gesture at when they say human nature is a screenshot of a build that has been shipping patches for 40,000 years. The methodology is what makes this thrilling. Open data, public reference genomes, ancient samples curated across dozens of institutions and shared internationally. This paper is possible because the scientific community treats the human genome the way Linux treats its source tree. As a commons, proprietary labs with siloed samples would have produced none of this. Shared data is what makes the pattern visible at all. Run this forward. Genomic archaeology is getting cheaper, faster, deeper. Within a decade, we'll have the commit history of every major population, every selective sweep, annotated with its driver. Plague, diet, climate, migration. That is not a threat. That is a library card. The bootstrap continues. We just finally started reading the logs. 5 stories in, and we're already rewriting biology with open data. Next up, pause F, story 5. Pause F. What happens when cybersecurity starts looking a lot like mining Bitcoin? Take the case against open source seriously. Mythos costs $12,500 per attempt. 100 million tokens. 10 runs to land 3 successful corporate network takeovers in simulation. By that math, security collapses into a budget line. Whoever outspends attackers is safe. Everyone else is exposed. The proof-of-work model favors capital concentration, and open-source projects run on volunteer time cannot match a Fortune 500 security budget. Concentration of defensive capability follows concentration of money. Closed by economics, if not by license. That argument fails on its own terms. Proof-of-work economics do not break the open-source calculation. They invert it in open source's favor. A single corporation hardening its proprietary stack pays the full token bill alone. A widely used open-source library being hardened by 5 sponsoring companies splits that bill 5 ways. 20 companies, 20 splits. Every dependency you share is a defensive cost you share. Linus's law extended into the token era. Given enough budgets, all bugs are shallow. Carpathy's recent suggestion to yoink functionality with LLA Wiesusrever without sug by dit amination parisens a vite yerbo. Lemislo, Moss was of extrading, grand, what the Brade defined Pereshid morn of the Tas Capri The token economy, taken seriously, requires the model itself to be reachable. A defensive proof-of-work system where only the pre-approved can buy in is not a defense layer for the commons. It is a moat with a guest list. The fix is not slower AI. The fix is open weights, open access, pooled defensive funds. The tools exist. The economics work. The only thing standing between us and a dramatically more secure software ecosystem is the gate. Staying with the theme of gatekeeping and open source, one of the oldest libraries in gaming just drew its own line, and it's got everyone talking. Stopping a flood with a tissue. Tooth comment on the SDL thread, and it's the whole segment in 5 words, SDL. The cross-platform library that powers half the games you've played announced they're banning AI-written commits. The maintainers are tired. The slop is real. Pull requests arrive with confident commit messages, plausible diffs, and subtle wrongness baked in like a raisin in a cookie. Take the maintainer's side for a minute. Defend the ban. Because the steel man here is genuine. Reviewing a bad patch costs more than writing a good one from scratch. When the patch looks competent but isn't, the cost goes up. When it arrives at volume, the cost becomes the project. A maintainer's time is the actual scarce resource in open source, and AI-generated contributions are an asymmetric attack on that resource, even when nobody intends harm. The ban is rational. The ban is necessary. The ban will not work. Here is the comedy. The contributors writing the worst AI patches are exactly the contributors who will not read the policy. The ones who do read it will simply not mention they used AI. Detection is a coin flip on a good day. So the ban filters honest contributors who used Claude to draft ADFE and disclosed it while letting through dishonest contributors who used the same tool and lied. The policy selects against transparency. That's the unintended consequence. The maintainers wanted less slop. They got less honesty. The fork comment is sharper than it sounds. Someone will mirror SDL, run an AI agent against the issue tracker, and ship patches faster than the upstream can review them. Most will be garbage. Some will be excellent. The maintainers will face a choice. Ignore the fork and watch it diverge, or cherry-pick from it and admit the policy was theater. Either path ends the same place. The real fix is not banning the tool. It's raising the bar on what gets reviewed. Require tests. Require benchmarks. Require the contributor to demonstrate they understand what they submitted in their own words before a human looks at it. Make the cost of submission match the cost of review. That filter doesn't care whether a human or a model wrote the diff. It cares whether the work is good. SDL's maintainers are not wrong about the problem. They're fighting it with the wrong instrument. The instrument that works is engineering. Gates, tests, reproducibility. Not declaration. Declaration, get forked. Moving on. The antivirus is the exploit. Windows Defender finds a malicious file carrying a cloud tag, and instead of quarantining it, the software carefully restores the file to its original location. That restoration runs as system. Point Defender at a system path you want to overwrite. Attach the right metadata, and the security software hands you the keys to the kingdom. This is RedSun, a local privilege escalation released this week against Windows 11, Windows 10, and Server with the April 2026 update. The author published it with a note that they normally just drop the proof of concept and let people figure it out. But this one was too funny to leave unexplained. Picture an immune system that, upon detecting a virus, carefully copies it back into healthy tissue and stamps it with a notarized seal. That's the dynamic. The mechanism designed to defend the host is the mechanism the attacker rides into the most privileged context on the machine. The guard at the gate, upon recognizing an intruder, escorts them personally to the throne room and apologizes for the wait. The craft in the exploit deserves admiration. Roughly 500 lines of C++. A clean compile line. Standard at 17. AdvaPO user. Nothing exotic underneath. Just a careful read of how Defender's cloud tag remediation interacts with NTFS junctions and file ownership, and a payload designed to land exactly where the system reaches when it tries to be helpful. The deeper question is architectural. Why does the antivirus have permission to rewrite system files at all? Reading them. Sure, that's the job. Hashing, comparing, flagging. Fine, but possessing the authority to overwrite arbitrary system paths as system, on the assumption that whatever it pulls from the cloud must be more trustworthy than what's already there. That's a design decision, not a law of nature. A reader on the thread asked the obvious follow-up. Linux ships local privilege escalations on a regular schedule too. The difference is the response loop. When pkexec or sudo ships a CVE, the patch lands in Debian by morning, and you can read the diff. When a Windows antivirus exploit ships, the fix arrives when RedSun decides it arrives. And the logic that made it possible stays behind a wall. The exploit is open. The fix is not. That asymmetry is the whole story. What if the most radical computer isn't the one with the fastest patch loop, but the one you can hold in your hands made of paper? Story 8. What is a computer for? Strip away the marketing. The screen, the apps, the notifications. And ask what work it actually does. James Summers wrote a post called The Paper Computer, and the question it raises is genuinely lit. Is vision, is quiet. Sit in an easy chair. Pen, pad. Handle the day's email by writing dates, checking boxes, marking up a printed draft on the couch. Then have all of that scanned, transcribed, dispatched into the digital world without opening a laptop. He tested it. Wrote the first draft of the post by hand in a small notebook. Fed it to ChatGPT. The transcription was nearly perfect. That's the technical hinge. Until about 18 months ago, handwritten OCR was a coin flip. Vision models couldn't reliably read cursive, couldn't infer whether a scrawled word was meeting or morning. Now they can. The bottleneck moved. The interface no longer has to be the keyboard. Run the constraints forward. What does a paper computer actually need? A capture surface. Paper plus a phone camera. A model good enough to transcribe rough marks and infer intent. A sync layer that pushes the result into the calendar. The inbox, the dock. 3 components. All of them exist right now. Summers puts his finger on something deeper. Space organizes information. The wall calendar a film crew uses to plan a shoot. The note cards laid out on a table that you stack and read the free stack and tape things to. The room that becomes the embodiment of a book you're writing. Physical objects carry a vocabulary of affordances that screens cannot match. Shape, color, position, size, weight, the ability to be grouped and pinned and cut without anyone having to code the interaction up in advance. The screen has been winning by default, not by merit. It won because the digital layer was the only place persistence and remixability lived. Once the digital layer can read the analog one, that monopoly ends. Brett Victor's dynamic land has been pointing at this for years. Rooms as computers, paper as interface, computation that lives in space rather than behind glass. The tools to build toward it are sitting on every developer's hard drive right now. The interesting question is, who builds the open version first? Because the alternative is a paper computer that quietly phones home every time you scribble a note in a notebook. Paper that phones home. We started this hour worrying about hardware that watches us. Story 9 flips it. A clock that refuses to behave. The accursed alphabetical clock. An alphabetical clock sounds like a joke. Sit with it for a minute and it stops being one. The constraint a clock works against is a mapping problem. Time is a continuous scalar. A clock face is a two-dimensional surface. You need a function that takes the first and lands on the second in a way a human brain can read at a glance. The standard analog clock chose proportionality. Angle equals time times a constant. 12 hours, 12 positions. Smooth sweep. That function is so naturalized, we forget it's a choice. The accursed alphabetical clock chooses a different function. Spell every possible time in English. 43,200 of them in a 12-hour cycle. Sort the strings alphabetically and map position to sorted index. The needle jumps. 801 lands near 859 because their spellings sit close in a dictionary. The mapping is total, deterministic, reversible, and completely unreadable to a human eye. Which is the point. The clock is a falsification experiment. It demonstrates that a clock face is not a clock. A clock face is one choice of transform sitting on top of a clock. Swap the transform and the same underlying quantity becomes illegible. That's a real claim about representation. Every visualization is a hypothesis about which mapping preserves meaning, and most of those hypotheses stay invisible until someone breaks them on purpose. Now the engineering due diligence. This runs in your browser. View source. The transform is JavaScript you can read, fork, modify, sort by German spelling, sort by Unicode code point, sort by syllable count. The representation is open, which means it functions as a tool for thinking rather than a fixed product. Compare that to every smartwatch face you've owned. The transform from time to pixels is locked inside an SDK, a watch store, a signing key, an app review process. You cannot build the accursed alphabetical clock for your Apple Watch and ship it freely. The objective function is set by someone else and enforced by the architecture. Ownership of the device is not ownership of the transform. Architecture determines outcomes. A web page that renders time through an arbitrary function is a small act of open computing. The author decided what time looks like, and so can you. The senior engineer commenter calling it dumb missed what it's for. It isn't trying to be readable, it's trying to be inspectable. Those are different design targets, and only one of them requires permission from a vendor to explore. The tools to build your own clock are already on your machine. If a clock can be a small act of open computing, what about a swap of two integers without a temporary variable? Why is the internet still arguing about it? Built a hot loop once that I was sure needed every cycle shaved, wrote the XOR swap. Felt clever, compiled it, looked at the assembly. The compiler had thrown my XOR swap in the trash and emitted a single move with register renaming. My cleverness cost exactly nothing because the optimizer was smarter than me, but it gained exactly nothing for the same reason. That's the XOR swap trick in 2026. A XOR equals B XO equals A XOR equals B. was a party trick when registers were scarce and compilers were dumb. The 6.5 EV20 had 3 registers. The Z80 had a few more. If you were swapping values in 1992, every memory access mattered, and a XOR swap genuinely saved you a 10th slot. Knuth was already warning about premature optimization in 1994, but for embedded work, the constraint was real. Then GCC happened. Then LLM in. 40 years of compiler researchers. Koch, Allen, Laudner, the whole lineage, turned register allocation into a solved problem. Modern compilers see XOR swap, recognize the pattern, and refuse to execute it. They emit whatever is fastest for the target architecture, usually a swap that doesn't even touch arithmetic units. The author of this piece does the right thing, writes the XOR swap, watches the compiler delete it, and instead of sulking, traces why. That's the entire game. Open compilers are pedagogical instruments. You can read GCC's source. You can dump LLLEMIR at every optimization pass. You can watch your clever trick get pattern matched and rewritten into something better. Close toolchains, hide that whole conversation. Your code goes in, machine code comes out, and you never learn what the compiler thought of you. The comment thread pulls on the right adjacent threads. SWAR for pseudo-SciMD when you don't have vector instructions. Conditional swaps using a mask where the XOR really does carry its weight. Error correction packets where Z equals A, XOR B, XOR C, and any one of the 3 can be reconstructed from the other 2. CNOT gates in quantum compilation where XOR is fundamental because swapping qubits is genuinely expensive and you build a swap gate from 3 CNOT. The XOR swap isn't dead. It moved. The trick that lost its job in scalar register allocation got promoted to error correction, SIMD masking, and quantum circuit synthesis. Places where the constraints are real again. The optimizer ate the old use case. The math kept finding new homes. That's a good run for one identity. This has been your daily tech feed for Hacker News for April 16, 2026. This podcast is entirely AI generated. Scripts by Claude Opus 4.6. Voice by Quen3TTS. Not affiliated with Hacker News or Y Combinator. Now go fork something. Read its source and leave it better than you found it. We'll see you back here tomorrow.